Hello people, this is Ms. Page and we are going to do a video on pages 7 and 8 of your student activities. This is student activity 1 and we are on TEK 7.7a. The topic of this stuff is to represent linear relationships using verbal descriptions. We're going to be putting stuff into this form y equals mx plus b, which is on your mathy chart. It's the very last thing on there. And is it the last thing on there? Math chart, or the first thing on there. Y equals mx plus b. Hold on a second. Let's look. Okay, so it's the first thing that's on there, y equals mx plus b. And I wanted to show y'all something in here because remember the topic is representing linear relationships using verbal descriptions. At the very beginning of the year, we put this in our journal, and the reason why we did is because we need to know what all these different words mean as far as which one of the operations we got to do whenever we see different words. And also, we got to know different words that stand for the equal sign. Okay? So let's move on, get to the problems. Problem 1. Problem 1 says for us to write the following phrases as mathematical expressions and to choose an appropriate variable for the unknown. So we are going to look her. This says twice the length, so we're going to call the length L. So twice that would be 2 times L, and that's all we have to do. Moving on to the next one. 3 times the number of pages decreased by 8. So we're going to call the number of pages n. And if you multiply 3 times n, that's going to look like 3 with an n right beside it, and it's decreased by 8. Decreased is one of the words that means to subtract 8. Yeah. Moving on. The number of dimes increased by 12. Number of dimes we're going to call d, since it is unknown, and we're going to increase that by 12, so that one's going to look like d plus 12 because increased is a plus. 1/2 the width, so the width is going to be w. So half of the width looks like 1/2 of w. Decreased, that means subtract 3 units. All right, 1/2 w minus 3. 1/3 the number. We don't know what numbers, so we're going to call it n. So 1/3 of n increased by 15. So we can add 15 to that. And we have taken all of these words and we have turned them into their expressions that they're equal to. And we are through with problem number 1. So let's do problem number 2. A larger number is 12 more than 3 times a smaller number. It wants us to write an equation to represent this situation. So we're going to start off by letting y represent the larger number, and we're going to let x represent the smaller number. So if y represents the larger number, then that means that this larger number is y, and is means equals. 12 more than means that we add 12 plus 3 times a smaller number. We don't know what the smaller number was, but we called it x up here, so we're going to call it x down here, and it's 3 times that number, x. So then it says the equation that represents the relationship between the two numbers is, if we put it into this format of y equals mx plus b, we're going to put y is equal to, and because of the commutative property of addition, we can switcheroo these things, and it's not even going to affect the value of this stuff, so we can switch these around. So I'm going to put 3x first, and then I'm going to add 12 to it, and it's in that format, y equals mx plus b. And that is going to be very important for our stuff that we're going to do tomorrow. So let's get used to seeing things like this with y and then a number beside the x plus something else. Okay. Problem 3. Moving on. The number of girls who won a superior rating at the band competition last year is 6 less than the number of girls who won a superior rating at the band competition this year. Write an equation to represent this number. So we're going to let y be, am I looking at the right one? No. Sorry, got to back up. We're going to make this x. We're going to let x represent the number of girls that won a superior rating this year, and we're going to let y represent the number of girls who won a superior rating last year. We can use either interpretation below to translate it into an equation. So the number of girls who won last year, that means y is 6 less than. Whenever we say 6 less than, it's going to be whatever it is minus 6. So we can't draw that arrow straight down. We have to put it over here. And then the number of girls who won this year, we see is x. So we're going to put x on this side. So look at that. Y equals x minus 6. Okay? But if they wrote it this way, the number of girls who won last year, still y, is equals the number of girls who won this year, that's x, less 6. Less means subtract 6. So y equals x minus 6 if it's written that way, and y equals x minus 6 if they use these words. It's the same thing. Who knew? Okay, let's put it all together. Y equals x minus 6, and that's actually in that y equals mx plus b format, except for this one, the m is equal to 1. Okay? All right. Moving on. Problem number 4. Okay. A coin collection. Move it down so y'all can see what I'm looking at. There it is. Hey. A coin collection contains nickels and quarters. The number of quarters is 8 less than twice the number of nickels. Write an equation to represent the relationship. Well, if y represents the number of quarters, and x represents the number of nickels, then the number of quarters, which is y, equals twice the number of nickels. The number of nickels is x, and twice that means we're going to multiply that times 2, and less 8 means subtract 8. So if we put it together, the equation that represents the relationship between the number of quarters and the number of nickels is y equals 2x minus 8. There we go. And that is in the y equals mx plus b. We're going to come back to it. Okay. Problem number 5 says that Joan deposited $200 in a savings account, and then she added $50 a month. Write an equation to show the relationship between the amount of money in her account and the number of months that she's been adding money to the account. So if we let y represent the amount of money in her account, amount of moolah in her account, and we let x represent the number of months, then we can write an equation in the form of y equals mx plus b, and it's a linear equation, and y'all are going to learn so much about that. It's going to be so fun. Okay, the amount of money in her account, we said up here that is y is equals blank dollars, $200 plus $50 times the number of months. The number of months is what we said x was. So we can multiply that times x, put it all together. Again, we're going to use that commutative property of addition that says that we can switch around addition stuff and it doesn't even matter. It's fine to do that. So the equation that shows the relationship between the amount of money in her account and the number of months that she has been adding money to the account is y is equal to, I'm going to put the 50x first, plus 200. So we're in the format y equals mx plus b. Okay. And then the last question. Jody has $200 in the bank. And Jody apparently is a he, because it says each time he rides the city rail, it costs him $3, which he pays with a debit card. Write an equation to show the relationship between the amount of money he has in the bank and the number of times he rides the city rail. Okay, so we're going to let y represent the amount of money that he's got in the bank. Amount of moolah in the bank. And we're going to let x represent the number of rides that he takes on that city rail. Number of rides. So the amount of money that he has in the bank is this right here, or y, is equals blank dollars. How much money did he have? $200. Decreased by, so we're going to subtract there, 3 times the number of rides. The number of rides was x, and $3 times that is going to be 3 times x. So we can still put it in the form where x is over here, but y'all need to remember that this is the same thing as $200 plus negative 3 times x. And if I switch this around, then we got negative 3x, or actually, but put y first, y equals negative 3 times x plus 200. Okay? So now it's in the form y equals mx plus b. Had to do a little bit of rearranging, and remember that when you're subtracting, that's adding a negative number. Okay? All right. Well, that is all, folks, for our student activity 1, and I am fixing to make the next video for student activity 2. All right. Have a great day. Bye.